Okay, so the key to this problem is figuring out what the original function f of x was. And since we have this form of the derivative where we have f of x plus h, it's going to be a good idea to actually flip the order of the terms. So instead of root h plus 4, we're going to write this as root 4 plus h minus 2 all over h. And when we start looking at this, we know that f of x plus h and f of x are closely related, and so we're going to rewrite the 2 in a form that's, and similar to the first term, since we have root 4 plus h here, let's see, 4 plus h there, I'm going to rewrite 2 as root 4 over h, right? Which lets us see f of x would be the square root of x, right? So basically what you can see here is they have a specific value of x, which sometimes they'll call a, right? And they're plugging, so f of 4 would be root 4, f of 4 plus h would be square root of 4 plus h, right? So that's how we know that this is the correct choice, right? So that we can basically show you this, and that's root 4 plus h, and that's what we're going to use, is basically if our f of x is equal to x to the 1/2, rather than going through the trouble of finding, like simplifying these radical expressions using conjugates or whatever, we can simply do the derivative of f of x equals x to 1/2. So f prime of x is equal to 1/2 x to the negative 1/2, right? And more specifically, we want to know the derivative when x is equal to 4, right? So I'm going to take 1/2, and then it's going to be 4 to the negative 1/2 power. 4 to the negative 1/2 power is 1 over 2, and this final answer is 1/4, right? So the key idea here is that basically they're giving us the right side of the expression here, right? The root 4 plus h minus root 4 over h would be essentially the right side of this equation. And then we're taking that to the left side, right? And they're saying, okay, well, if f of x is x to the 1/2, then we can take the derivative, plug in 4, and it will be done.